Hi, in this video I'll show you how to calculate floating rate payments on a swap, fixed rate payments on a swap, value a swap, and then calculate the swap rate. So, first of all, to value a swap, it's necessary to determine the present value of the fixed rate payments and the present value of the floating rate payments. The difference between these two present values will be the value of the swap. So, as you can see, it's shown in this equation. So present value of the fixed rate cash flows minus the present value of the floating rate cash flows will equal to the swap value. It's very simple. Now the inputs that go into this are notional amount, number of days in each period, for example, number of days in a quarter, futures prices corresponding to swap payments, forward rates, and periodic forward rates. Obviously, you would also need to calculate those floating rate payments and fixed rate payments. Now the swap rate is calculated based on this formula, and we'll get to that. Just remember that there is this relationship where you divide present value of floating rate payments by this amount, and I'll explain where this basically formula comes from. So SR is the swap rate, days sub basically T is number of days in period T, FDF is just a forward discount factor corresponding to time period T. Okay, so let me illustrate with this example here. So here we have a period start 31st of March. Notional value is 40 million. Days in a year is a convention, 360 years. And I'm assuming here that swap rate is 6%. Now, it doesn't matter what you assume the swap rate to be. You can always work out this exact swap rate later on. But I'm just choosing this just to illustrate what's going to happen to the value of the swap when I choose a specific swap rate. Okay, so the first thing we need to do is we need to take a look at this table here, and I want to explain what these basically each columns of data mean. Quarter start refers to the settlement date of a futures contract that has basically corresponding financing rate called forward rate, based on which the cash flows will be calculated. For example, here this period January to March, basically you see 5.7%. Okay, there is no futures price here. So 5.7% is the rate at which you borrow from January to March. So these are 3 months borrowing windows. Okay, so in this case, the specific derivative instrument that's used to derive forward rates from is called Euro-dollar futures price or Euro-dollar deposits or CDs, whatever they call them. And basically these are 3 months rates after a certain period. For example, April, and if today was 31st of March, let's say if I'm taking a look at July, this futures price of 94 represents the price of a Euro-dollar deposit. Basically, you know how much the borrower would be paying, or how much the investor would be willing to invest at, you know, the rate that they would seek to receive 3 months from now for 3 months. So 3 months from now basically would be from 31st of March to July. There is 3 months time period, right? And the time it's borrowed for is between July and September, which is also 3 months. So 3 months rate from 3 months from now would be calculated by subtracting this 94 from 100, which is 100 minus 94 is basically, so the forward rate for that period would be just 100 minus 94 divided by 100. So that would be 6%. So the forward rate would be 6% for that period, which is basically a 3 months forward rate 3 months from now. Okay, starting from 31st of March. So this is how you calculate and work out the others. For example, we got the 6%, and to get this 6.3%, you would subtract this from 100 divided by 100. And so it goes. As you can see, the last one is 93, so this is going to be 7. So we got the forward rates, or basically $0 futures rates, sorted. We have them. The next step here would be to calculate basically the floating cash flow at the end of quarter. Remember, the value of the swap was the difference between the present value of the fixed rate cash flows and the present value of the floating rate cash flows. In order to calculate the present values of both, we need the cash flows themselves. So that's what we're going to get. We're starting with the floating cash flows, and it's very simple to calculate. As you can see, floating cash flow for each period is just the notional value times the basically the prorated time times the rate. In this case, we're using 5.7%, which is the borrowing rate, and 5.7% annualized rate, basically prorated to the quarter, which consists of 90 days, times the notional value would give you the amount. Okay, so how about the second one? Well, it's going to be similar. So 5.9% times basically 5.9% prorated. In other words, 5.9% multiplied by 91 divided by 360 multiplied by 40 million would give you 596,556. Okay, so just to show you, in case you were not quite you didn't quite get it, basically we're getting the cash flow for that period by taking 40 million, multiplying it by the rate. In this case, the rate is, as you can see, 5.9. Okay, 5.9%, and the number of days in the 91. So it's gonna be 5.9% times 91 days divided by 360. Okay, so this gives you 596,556. So that's how you got this. Okay, and following the same basically rule, you can calculate all of these cash flows. So we got present values of basically floating rate cash flows. The next step is to calculate fixed rate cash flows. Now, if we have swap rate of 6%, it's not difficult to do. However, in the next step, when you need to calculate the present value of those cash flows, you need what we call forward discount factor. So I'll show you how you calculate that as well. So the first thing you need to do in the step of calculating the forward discount factor is you need to calculate period forward rate. So period forward rate basically is the rate that corresponds to the exact number of days in that basically quarter, in that period. In this case, it's a quarter, right? So you've got 90-day quarters, 91-day quarters, in some cases 92-day quarters. So in this case, you need to take 5.7 multiply by 90 divide by 360, and you should get this 1.4250. Okay, so just to illustrate. So where did we get that 1.4250? So well, we took 5.7%, okay, and then multiplied by 90 divided by 360, and we got that rate. As you can see, it's 142.50. Okay, so this is basically equal to 142.50%. So what do you need to do to get the discount factor for this period? Well, it's very simple. So you just take 1 and divide it by 1 plus 0.01425. That's it. And that would give you basically a discount factor of this 0.98595, etc. Okay, so I'm just gonna round it up to 4 decimal places, 98.59. So it's gonna be 98.59. So that's how you get all of the basically rates, so discount factors. So the thing is that when you calculate the next one, you use the previous one multiplied by the 1 plus the rate raised to the negative power. So what I'm really doing here is, when I'm calculating the next period's forward discount factor, I'm using the forward discount rule in calculating discount rates. If you remember, we can actually value a bond using forward rates. We're using the same principle here. So to calculate the next period forward discount factor, so this is forward discount factor for period 1, and to calculate forward discount factor for period 2, I'm just doing this: 0.9859 times 1 divided by, so what was the rate, periodic forward rate for the next period? It was 14914. So it's gonna be 1 plus 0. Let me just check. So it's 14914. So it's gonna be 0.014914. Okay, so that would basically give us that discount rate of 0.9715. Just round it. I'm just taking 4 decimal places again. 9715. So 0.9715, and so it goes. To calculate the next one, for example, to calculate the forward discount factor for the third period, you would take 0.9715 and multiply it by 1 divided by whatever that the next period's periodic forward rate is, 153.33. Okay, so it would be basically plus, oops, it's going to be 0, 153.33, and so it goes. So I'm not going to just do all of it, obviously, so I'm just going to go through and explain where we got the this column from. And as you can see, it's just basically the the floating rate cash flows, or nominal cash flows, times the forward discount factor. That would give me the present value of that floating rate cash flow. So I just multiply each by FDF, or forward discount factor. Okay, it's very simple. The cash flow for period 1 multiplied by discount factor for period 1, cash flow for period 2 multiplied by the discount factor for period 2, and so it goes. And so when you add up those cash flows, you should have the PV of floating rate cash flows. Now, similar principle applies to fixed rate cash flows, except it's even easier. So for example, you first calculate the fixed rate cash flows, and they're gonna be easy. All you need to do is, as you noticed, you've got basically the same rate, same swap rate of 6% times the notional value, but you need to take the number of days into account. So some quarters have 90 days, some quarters have 92 days, etc. So that's the reason you don't have the same amount. You know, if you had the same number of days in each quarter, all of these values will be 600,000. Okay, so this is very simple. And PV of fixed rate cash flows is basically this cash flow discounted by the discount factor. In other words, just take this cash flow multiplied by the discount factor and you'll have these cash flows. So we're using the same discount factors to present value the floating rate cash flows and the fixed rate cash flows. So when you sum up those values, you're gonna have 4.5 million, etc. Okay, and basically the difference between these two obviously would be the value of the swap, right? These are the PV of floating rate cash flows. These are PV of fixed rate cash flows. As you can see in the formula, the swap rate, or the swap price or value would be the difference between them, right? And basically that's what we're gonna do. As you can see, this is the difference. This is the difference between the PV of floating rate payments, PV of fixed rate payments. Now, how do you identify who is basically have a positive value, who has a negative value? If you're a fixed rate payer or floating rate receiver, you're benefiting. So you have $335,944 of positive value. So the swap is basically gained in value for you. It's being profitable for you. And if you're a fixed rate receiver or a floating rate payer, then it's negative value. Notice that it's exactly the opposite of this. So if it's a positive value, someone's gain is someone's loss. Okay, so what we need to do here is work out the swap rate. That's the final step. So notice that I just assumed a 6% rate. So at the inception of the swap, the terms of the swap are such that the present value of the floating rate payments is equal to the present value of the fixed rate payments. At inception, the value of the swap is equal to 0. This is the fundamental principle in determining the swap rate, i.e. the fixed rate that the fixed rate payer will pay. So we need to choose the swap rate so that this will be 0. So how do we do that? Now notice that I mentioned this formula earlier, and this has to do with this formula. So notice that swap rate is equal to the PV of floating rate payments divided by this. So where did it come from? Well, it's very simple. So let me show you where it came from. Remember that PV of fixed cash flows is equal to swap rate times the notional amount times, basically, let me put it in brackets, the sum of days T divided by 360 times forward discount factor T. So this is how actually you calculate the PV of cash flows. So SR is the swap rate, N is the notional value, and this is the sum of the days corresponding to a specific period divided by 360 times the forward discount factor corresponding to a specific time period. So basically this is the PV of those cash flows. But remember that PV of fixed cash flows should equal to the PV of floating rate cash flows. So we just basically interchanging the top of the formula, we're just swapping it with the floating rate instead of fixed. So then if you do that, what we're really doing here is saying that swap rate equals to PV of fixed cash divided by so divided by N times T1 and days T 360 times F df T. So we're just saying that because the PV of fixed cash flow is equal to the PV of floating cash flow, this should be true of floating cash flow. So it's the same thing in the denominator. The denominator is the same. So from 1 to N times days T divided by 360 times F df T. So we just basically transforming the same formula here. And if you actually notice that we did this in the Excel. So I just simplified the formula, and here I just highlighted how I calculated it. So these are the prorated time, okay? So days T divided by 360 basically. So this is days divided by 360, okay? And here is the discount factor times this. Okay, so remember in the formula you had days t divided by 360 times the FDF, so that's exactly what it is, each of these for each period. So when you add them up, you're gonna have this number. It's 1.8934 and little change. So all you need to do is add up, in other words, take the sum and multiply the sum by the notional value. So that's what you're doing here. So take the notional value from above, which is 40 million, okay, and basically multiplying it by this sum, okay, and that's going to be 75,737 something. And basically to calculate the swap rate, then you just need to take the PV of floating rate payments, which we have, PV of floating rate payments, 4,780,220, and you multiply it by this. Okay, that's what we're doing exactly. So this, the PV of floating rate cash flows, and divided by basically this amount, and that's how you get the exact amount of swap rate. Okay, now here's what happens if I actually plug in that number. So let me just paste it as a number. So if I plug it in here, I should see exactly 0 in the swap rate, because that's what the swap rate should be at the inception. Okay, let me scroll down and you see it's nothing here, it's 0. And that's how you actually calculate the swap rate. Obviously, instead of calculating this, we could actually figure out the swap rate by sort of iteration. Okay, instead of, let's say if I put 6%, I had a little bit of, well, not a little bit, but $235,000. But if I put 6.2, I would be closing in. It's going to be smaller, right? So then I would notice that I need to choose a little bit higher, and I go here, it's going to 8,000. And if I go to 6.4, then I would notice that I have maybe went a little bit higher, because now the amount is higher than the previous. So then I would focus at somewhere in the middle, 635, and see where, go from there. So I hope it's clear. So just to remember, just to recap. So the swap value is the difference between the present value of the fixed rate cash flows and the present value of the floating rate cash flows. The swap rate is basically the PV of floating rate payments divided by this expression, which is derived by this formula at the top. Okay, and that's it. So we've learned in this video, we've learned how to calculate the forward rates, how to work out the floating rate cash flows, how to work out the fixed rate cash flows, the value of the swap, and the swap rate itself.